Hello friends, today we are going to discuss on bending test. The main aim of the experiment is to conduct bending test for the given specimen to determine the different parameters like moment of inertia, maximum bending moment, and modulus of rupture are also nothing but the maximum bending stress at failure point and modulus of elasticity or Young's modulus. Operators required for this particular experiment is universal testing machine, dial gauge, vernier caliper, and wood specimen. The procedure following for this particular test is firstly the given specimen dimensions are noted. The specimen is placed on the supports and is fitted on the universal testing machine. Dial gauge is mounted on the UTM at the appropriate position and adjusted to read 0. The UTM is adjusted to have suitable load range. The machine is switched on and bending load is applied gradually. For every zero point 0.5 kilonewton rise in load, the corresponding dial gauge and also the scale reading are noted. The load is applied until the specimen breaks and breaking load is noted. Finally, whatever the value we are got, based on that, we have to draw the graph of deformation corresponding load. Observations following in this particular specimen is to measure the width of the specimen B and depth of the specimen D and full length of the specimen L and distance between the two rollers L, that is small l, we need to measure first. Tabular column followed in this particular specimen is to, based on the specimen, we go for the load W and deformation delta and Young's modulus. And formula used for this particular experiment is on the bending test to identify the moment of inertia I equal to BDQ by 12 and maximum bending stress, that is M equal to WL by 4. This is for the purpose of, because the specimen is placed in a simply supported manner, that's why we go for the WL by 4 is the standard formula for the bending moment. Then the third is the maximum bending stress or the modulus of rupture or the flexural modulus that will be identified by the bending equation, that is m by I is equal to sigma by y. In this, sigma equal to m by I into y, and y is nothing but the distance between the neutral axis to the outermost fiber. That is, in this particular specimen, that is the rectangular cross section, that's why we are using a d by 2, that is depth by 2, and m is nothing but bending moment, I is moment of inertia, and sigma is bending stress. And the deflection formula we are using for to identify the Young's modulus. This deflection formula is also for the simply supported beam with central point load condition. That is, deflection delta is equal to WLQ by 48 EI. This W is the point load or the load acting, and L is the distance between the two roller center, that is small l. And finally, by using this deflection equation, we modify and E is equal to WLQ by 48 delta I. In this, the ratio of the W by delta is nothing but the slope of the load deflection at 8 point. That will be getting by the graph, and this value substituted in the equation, finally we got the E value. In this, the m is bending moment in Newton millimeter, I is moment of inertia in mm to the power 4, and sigma is bending stress, and y is distance between the neutral axis to the outermost fiber, and E is the Young's modulus in Newton per mm square, and L is the full length of the specimen, small l is the distance between the two rollers. And experimentation of the bending test we will go through now. Thank you. So this is the UTM machine. So first we fix the specimen, bending specimen. Bending specimen is we are using commonly the wood. The wood specimen will be fixed in this manner. It is look like a simply supported beam condition. So you can observe the central point load is acting. That is known as the point load is acting on the center. And also you have to observe the center distance between the one roller to the another roller center distance is known as what? The L, small l, we are using in the deflection formula. This is the dial gauge values you can observe. This is the measure for the purpose of the deflection or the deformation. This dial indicator is the value, we take the value of the load. The load is commonly 40 kilonewton we are using, and you can observe, so the material is breaking, and so the material finally break. After that we take the reading, final reading. This is the final reading. You can note down the values. After experimentation, we got different observations, values like breadth of the specimen and length of the specimen and depth of the specimen, and also to find out the moment of inertia, bending moment, and maximum bending stress, and by using a deflection formula to find out the Young's modulus. Now you are seeing the values of the breadth of the specimen. The B is 50 mm and length of the specimen 435 mm and depth of the specimen is 27 mm. Based on that, the moment of inertia is BDQ by 12 for the rectangular cross section we are using, and finally we got the value 82012.5, 82,012.5 mm square. Maximum bending stress value also got by the equation of WL by 4 for the maximum bending load condition. And maximum bending stress formula will be bending equation M by I is equal to sigma max by Y we are using. So these values you have to get from the tabular values like load and deformation. So based on that, we identify the Young's modulus value. So you can see here the Young's modulus value will be calculated in this way. That is PL by 48 into delta L, and maximum bending stress sigma value. So we can get it M by I into Y. Then maximum bending moment value like this, and moment of inertia is also VDQ by 12. Substitute the values and get the answer. So finally, we got the Young's modulus value. So 2.25 into 10 to the power 3 Newton per mm square, and maximum bending stress value and maximum bending moment value and moment of inertia value we got. This is the final result of the experiment. Thank you.